So our persistence tool in this world is something called JPA. If you've come at this before, if you've ever used a tool like something called Hibernate, that is in fact the precursor, a predecessor of JPA. A lot of the concepts that you find in Java Persistence API, JPA, actually came out of Hibernate. And the implementation that you can use for JPA, one of them happens to be Hibernate. The one that we're using is the one that you get by default, which is called Eclipse Link. It used to be called Top Link. But as far as the basic capabilities, they both represent a way of storing data in a relational database without you having to know all of the low-level details or to have to worry about writing those things. Now, I showed you a little bit about what's underneath. In fact, JDBC, the Java Database Connectivity API, is actually underneath all of this, and if you had taken this class a few years ago, that's what you would have had to learn how to program in. So, and that still comes up. You know, you might find if you do this for a living, you'll run into systems that are using that underneath. You might actually have to dig into that. It's not that difficult, but it's a level of detail that you'd rather not have to get down to if you don't have to, and that's where JPA comes in. So, the concept of entities, that is the terminology JPA uses for the classes that you define as the mappings. Remember, we're talking about ORM, object relational mappings. So the entities represent those mappings. And fortunately for us, a lot of it can be done for you in terms of setting it up. You can go either direction. You can either write your classes and essentially create your entities as Java classes, and then have the tools like NetBeans will create the database structure for you. You know, once you hook up the database that you're going to use to it. That's not typically the way I've used it, because in fact more often in the real world you'll find that you already have existing databases, okay, and there are existing tables and people are using them for other things, and oftentimes what you're doing as a web app is providing front ends to those things, okay. So, and also I have found in this particular class, because people are already experienced doing SQL, you know, databases and design, which is why I make it such a strong prerequisite, it gives you quite a leg up, because NetBeans allows you to go the other direction too. Okay, so assuming that you are doing your database design first, which of course is driven by the functionality your term project is going to have, you know, if you have users, then you have to have some kind of user storage representation. If you're going to have, you know, if you're selling products, you have to represent those. If your users are customers, and customers can place orders, and the orders consist of line items, and the line items consist of products, etc. That's a database design that you have to come up with. So I have found, and people have usually been very successful doing this, is that if you work on that, which you already should kind of have had experience trying to do, then actually hooking that into your project is pretty straightforward, because as you'll see from your next assignment, which you may have started already, I guess, that's exactly what it does. It shows you how that works, okay, kind of a standard way of, that's the tutorial that shows you how to build a JSF, what they call CRUD, well, you know what CRUD is, right, front end, for a relational database. So that's in fact what you will do, you know, once you get your database design more or less solid. And you can, that doesn't mean to say that you have to get it right the first time, because you can recreate it, you know, again and again if you have to, and then the amount of hand tooling that you have to do as far as getting access to the database is pretty easy, okay? So that seems to have worked in the past, and I hope that's going to work for you. Anyway, so this glue for your Java EE projects is nowadays it's called JPA, and the entities are what represent that. The entity itself is nothing but a POJO, okay? It's just a basically a class, a very simple class, doesn't require implementing an interface or anything like that. All you essentially have to do is tack on the annotation @entity and a few other things, and then all of a sudden it becomes magically a mapping to an underlying database. Just so you know, because we'll run up against this again, or you may read it in documentation that you come across. There was the concept pre-EJB3, we're now up to EJB 3.2 as far as the specification, the enterprise Java means, of which JPA is sort of, it's not part of it, but it's associated with it. There used to be, now we've already talked a little bit about this, but I'm going to go into this in more detail. We talked about session beans, stateful, stateless, singleton, message-driven beans. Those are the real current versions of EJBs, of enterprise Java beans. There used to be, in the previous versions of the EJB specification, something called an entity bean. That was yet another one. That has been deprecated. That's the fancy term for getting rid of. In the EJB3 specification, okay? So that has been subsumed by JPA, okay? That's just historically what happened when people didn't like the way entity beans worked. The Hibernate people and the Java EE people and the Spring people got together and said, come on, let's make some sense out of this. And so they commonly came up with this JPA specification, which happens to be part of Java EE, but if you're a Spring programmer, you can also use it just as well. And again, it has a lot of the flavor of Hibernate, so if you know anything about that, you can pick basically almost all of that up and use it here. So no more entity beans per se. So an entity class simply represents a table in the relational database. The class variables or properties are essentially the columns in the table. The instances represent the rows. Okay, so if you create a new entity instance, what you're doing is essentially adding a new row to the table. Okay, so that's really what's going on. So it's actually pretty straightforward. Generally speaking, and this is the point you may, I'll take a look at our little simple message app later to point this out. You might have said, what the heck is this facade thing? In general, it is a bad design idea to have your business logic access these entities directly. You essentially, you can do that, but it's not good from a maintenance point of view. As the system gets bigger and bigger, that becomes more and more of a problem, even though it doesn't look like it when it's small like yours. So the rule of thumb is that the business logic or any of the other components shouldn't necessarily touch the entities directly. That is in fact where that abstract facade and message facade, is coming from. Okay, that's the thing that's shielding the outside world from having to know too much about the entities. Okay, because that's really, and the entities themselves are in a sense a shield from having to know anything about the underlying database. So this idea of layering and abstractions is very common. You see it all across all architecture, system architecture. So that's the idea. The session facade is what you call an architectural pattern that you're going to run up against again and again, particularly in these kinds of systems. In terms of some of the mechanics, every entity has to have a unique primary key because that's essentially how it finds it, okay, or how it manages it from a low level. The primary keys can be simple, and generally speaking, you'll see the primary key being some kind of a unique sequential field. Okay, there are many choices for how you do that, but the whole point is it has to be unique. Sometimes, as you know from database design, sometimes your keys are what you call composite. So you can make it up from I'm not sure what wouldn't be unique. I guess Social Securities are unique, but yeah, something else where you have two fields that together, or 3 fields, or 10 fields, or whatever it is, will generate a unique ID. Okay, that's a composite. And in the case, what you'll run up against, you probably won't necessarily see that in your own code, but the way it gets actually implemented in this world is that a third table is actually usually created it's essentially a separate class that represents the composite key. We'll see that again when we talk about things like many-to-many relationships too. As I said, you can convert any basic POJO class by adding the entity annotation. From that point on, the JPA manager you're using will create them, read them, update them, delete them, as long as you use the mapping code that is part of the the entity. In terms of the only requirements, of course, you have to have the right package pulled in. Can be public or protected, and has to have a no argument constructor. So that's like basically like a bean. And the business about not being declared final. Okay, no final in the class and no final in any of the innards of it. Okay, and that's it. Other than that, it's just a regular class. How do you get access to the insides of the entity? Which ultimately, when I say that, that of course means getting access to the database. It's through the entity's properties, the entity instance, okay, which is the row ultimately. And this, what I'm saying is, how do you get at the columns in the table? So you can either obviously do it directly if you're inside the class, or you can use getters and setters, or accessors and mutators, to use the formal term. The supported types that JPA supports, all the basic primitives, ints, longs, floats, string, any other type that can be serialized, and enumerations, which is kind of convenient too. That enumerations can make your code a bit cleaner, so they support those too. They can be other entities, or even other collections of entities. Or, and I don't have an example of this, you can actually have classes embedded inside of your class, and those, in fact, can also be legitimate. And that obviously the what gets created in the database is more complex. You know, it might be a third or fourth table that is uses multiple keys to get at it, but that's also doable. One thing to note, and usually you don't, in a lot of cases you don't have to do anything, but by default if you're using this annotation, all of the properties, all of the fields will automatically become part of the database. Okay. As a matter of fact, you can by simply giving a configuration command of create in one of the XML files, you can have, if the database doesn't exist, and assuming you can get at it and have the proper privileges, JPA will in fact create all of the tables for you on the first go round. So if for any reason you don't want one of those fields, I mean, you could have any number of extra fields that you use for computations or something like that happen to be part of the class. If you don't want them to be in the database, mark them transient. Or, are you familiar with there's a Java, that's also a Java language construct too, transient. If you say that, it has a slightly different meaning there, but it has the same idea. In other words, this is not to be stored anywhere. You can get rid of it at will. So again, that if you run into it, you might say, how the heck did I get that thing in there? I didn't really want it. Simply annotate it. So this idea of a persistence context comes up again and again. It's an abstraction. It's not a particular hunk of code inside the EE server, but you can kind of think of it that way. This is the manager for your persistence. And basically, a particular persistence context is going to represent a particular set of entities that JPA is going to manage. Now, you can actually have multiple persistence contexts going at the same time. And that would be, let's say you're talking to multiple databases from your application. You would simply define each of them as a separate persistence context, and you could keep them separate like that. So the way that this all works is that inside this persistence, context manager, the entities as you need them will be created. They'll be updated. They'll be read from. They'll be deleted, etc., based upon how you interact with them. But all of the details of how that happens underneath is you don't have to worry about. That's the beauty of this. Now, the thing that you interact with after the persistence context, you have to specify so it knows, what's my, what kind of database am I working with. But after that, you're actually the code that you're dealing with is something called an EntityManager. And that's what you actually interact with. So from your point of view in your application, there's essentially the EntityManager, which you get a handle on. Okay, it'll give you one. This is where injection comes in. This is one of the things that you can get injected into your own code is an EntityManager, and from that point on, you can use that to actually talk to the persistence context and ask it to do things. So the entities are what are the currency that go back that you're referring to there, and then the persistence context takes care of all the details for actually creating them, destroying them, updating them, etc. Okay, so for example, when a transaction, now I'm using the database transaction concept, where you have the idea of multiple things happening as part of a transaction. You would begin the transaction, you'd end it and commit it. That idea. The persistence context text will flush any changes you made out to the database, again, so you don't have to worry about that. Inside of a transaction, basically the default behavior is if you're inside of a transaction, and as we'll see, there are two different kinds of transaction management or persistence management. One is called a container managed, which is the simplest kind, which is the one that you should use if you can. And then there's something called bean managed or application managed persistence. In that case, you have to do more of the work, but it also gives you more control. So generally speaking, though, let's take the simplest one, the one that you would normally use, container managed. If you enter into a method, and that method does stuff with the entity, creates it and updates it and whatever. If any exception is thrown in there, a Java exception, all the recent changes inside the method will be rolled back automatically. Okay, so it's kind of one of the things about this is once you're inside of a method, it's from this perspective, from the persistence perspective, it's kind of an all or nothing. You either get it all right or it's going to roll it all back. Okay, so as we'll see later, that leads to another rule of thumb, which is to keep your methods pretty simple and straightforward, so that you can break them in at logical operations. Okay, so that you don't want to make it so that it does like 10 things. You probably want to make it more atomic, and that will, which means that you can use the container more than having to manage it yourself using the other style. Okay. Another thing that happens, and you don't actually need to know this, but it'll happen underneath for you, and this is part of the nice aspect of Java EE in these servers, is that in terms of scalability, if the system is getting memory bound with a lot of these objects, it has the capability of it's like doing paging, in an operating system paging. It has the capability of writing them out to secondary storage, and as soon as somebody makes a reference to it, it can go back and bring them in. Okay, that's where the least recently used business comes in. So that is a scalability bonus that you get from using this. Otherwise, you'd have to manage that. This way, you don't have to. And there are other operations that you see here. So, an EntityManager instance, that's what you need a handle on to do this. The states, this is the, you can think, I'll show you a picture of this in a second. You can think of this as a state transition diagram. The 4 states are, and we're talking about the entity, is it a new thing? Is it already under management? Has it been detached, which is a little harder to explain, or has it been removed? That's easy. That means it's you had it and now you're letting it go. That you don't need it anymore. Normally, and this is the thing with the whole convention over configuration concept, we see that again and again. In other words, whatever you do most of the time, make that the default, and then allow you to override it when you need to. So here, the idea is, with container managed especially, the idea is that it will do all of this for you. In other words, you don't have to say begin the transaction, end the transaction, commit, rollback. It will. That's what it does, unless you say something else. Okay. Again, that might not be fine enough control for you, but in general, you can, if you can make use of that, it saves you a lot of work. So these are the lifecycle states, new. The entity is instantiated, but isn't associated with the PC yet, okay? And it's also not linked to the database. So it's basically in this kind of not quite born state. Managed. Now that moves it from the new state to the persistence context. So at this point, any changes that you make to it get written out to the database. And then again, that happens automatically. You don't have to say that. Really, the only thing you have to mostly worry about is if there is an exception, because the exception is what will keep things from behaving the way that you think. In other words, if you have an entity and it's in a managed state, and you make a change using one of its like setter methods, if you make a change there, it will automatically be made to the database for you, okay? And the only time it wouldn't do it would be in case there's an exception thrown, okay? Or you can actually, you can either say flush is one of the EntityManager methods. If you say that, you can force it to happen sooner than you want, then it would normally do it. Now, detached, that's the third state. It means it exists, but it's not currently managed within the persistence context. This happens in a couple of different ways. In order for you to get it from new to managed, there is one call you have to make. It's called persist. And as soon as you say that for the thing, then it becomes managed. If it's read in through a different persistence context, that is a different transaction, or the object was serialized. Okay, in other words, it had been moved because it wasn't being used. It had been moved out to secondary storage, and it's being brought back. Then it's in this detached state. These entities. Let me mention something, because later on we're going to run into this concept again when we talk about EJBs, because the EJB manager, which is not the same as this, but works in a very similar way as far as transactions are concerned, also does that for the EJBs, for those like stateful EJBs. So you'll see this concept again. So that's the detached state. You can also, there's another method called clear. You can force an object to go into a detached state for whatever reason. And also, after it's been removed, that's another command you can issue, or if it's flushed and committed, but you're still doing other stuff, then it will also become detached. In other words, it gets cleaned up at some point after that, but it goes into this third kind of, nebulous state, okay? And then lastly is removed. That means the object is to be deleted from the database, but it doesn't actually happen until the transaction is committed or you call flush, in which case it'll force it to happen, force it to delete. Other than that, it's ready to go, and the system will decide when it's time to release it. So those are the four basic states in the JPA world. So here is the basic set of API. I mapped the API method calls to how it gets from one to another. Now, this is if you can call these yourself, but in fact, a lot of this is happening underneath the covers for you. So you oftentimes the only thing you might have to call is persist, and occasionally merge, and maybe flush. But many cases you won't ever have to call any of these, except for persist. You have to say, okay, you created it, now I want to hook it up, let's go. But this is the idea, is that the entity instances are being moved from between these states, and that's what JPA, this is what the persistence context is actually managing, is this process. So the API, you can look it up, has a whole bunch of methods. So what does it do? Basically, it does the creation and removal of these things. You use it to find entities by the primary key. It allows you to run queries, supports, again, transactions, make sure that the business logic gets carried out and the database is updated properly. And as I said, there are two basic kinds: container managed and application managed, sometimes called bean managed. Sometimes you'll see these terms as CMT, which is container managed transactions, and BMT, bean managed transactions, but they're the same thing as this, okay, just different names. So container managed means the enterprise container part of the server is doing this for you, and that's, if you see the term JTA, which you'll see if you look inside the persistence.xml file, that's what it's referring to, is there's this is the part of the server that's actually doing the transaction handling. The container is responsible for injecting the entity manager for you. This is the easy way of doing this, and it's also responsible for disposing it. Okay, so you don't have to do anything about creating it. I mean, there are ways of doing that using a factory method, but you don't have to get to that level if you don't want to. Again, another reason to try to use the container version first. Again, the real trade-off between this and the other kind, you have to write more for the other kind. Again, it gives you more control. But the big difference is that if any exception is thrown inside your method, the whole thing will roll back. Okay, so that's why you want to keep them pretty small and to the point, so that you're not rolling back large chunks of logic from the database. But it will do it for you. But then it makes it harder for you to manage. So here's the injection happening. Okay, @ persistence context. That persistence context here means give me an entity manager to use. It also, and most of these annotations, by the way, I'm only showing you usually the simple version, but most of them take attributes, like the named named took a value equals quote blah blah blah. Those are the attributes, and most of these have attributes that allow you to tinker with them. But this is essentially injection. Okay, I know I conversed with a number of you on your homeworks, giving you ideas as to how injection works. But that as you'll see is a very powerful concept that's been added to Java EE over the years, and it appears in different ways. It might not be obvious that in fact that's what's going on here, but that's really what it's doing. In other words, you're saying at this point, I need one of these things. Please go find me one and instantiate it for me. And that's where you'll see that again and again. If you see @inject, if you see @EJB, as we'll see later on, if you see @resource, those are essentially, even though they're slightly different, in every case they're really doing the same logical thing. They're going out, trying to satisfy your request to produce one of these things so that you can use it. Okay? That is now everything, by the way, is moving towards CDI, that specification. We're now kind of in fact, as I did a lot of reading over this, as people were asking me questions, you could actually, for almost everything, use @inject nowadays, and it will figure it out for you. I'm not sure if it would do it here, but well, maybe not. No, actually, it probably even could. But that's where everything is going. So if you think of it that way, that's really what's going on, and hopefully that will make a lot of these annotations make more sense. So now you see, guys, that I've been conversing with, why, if I said you needed a session scoped bean that you created, and you said I needed it to capture the counts or the dirty, the naughty words or something like that, I said what you do is if you need it here, okay, and you created it over there, if you need it here, what do? Inject it. In other words, if you have a session scope bean here and you've got some other kind of Pojo here or some other kind of bean here, you say, I need one of those. It's the same thing, idea as this. Say, inject it. In other words, the system will go out for you looking for one of these kinds of things, that whatever it is you're specifying, and it will see if it can find one for you and create it for you and give it to you. In the case of session scoped, there's a good example. If you created a session scope bean, just a regular one, not even a session bean, not a stateful. Okay, it'll do that too. But let's take the simple one, a named NAMED bean, and you marked it as session scoped. Okay, you know what that means? It means it's available. It's managed by CDI. Its life is the entire session, the user's session, until that goes away, which normally is only when they leave or shut down the browser. Though of course, you can invalidate the session early if you want. But it will live from that point. If it didn't exist when you asked for it, what will it do? It'll create it for you. Okay, and so it'll go through its initialization, and that's where you start with. If you ask for it the second time, it'll go look for it, say, assuming it's still around, and then it'll give you that one. Okay? You ask for it the 100th time, it'll do the same thing. Okay? If for some reason it goes away and you ask for it again, it'll create a new one for you. Okay? So that hopefully that answers kind of some of the questions that you were having about how do you get at one managed bean from another. That's the answer. Okay? And that concept, you'll see, comes back again and again, because that could have just as easily been an EJB, one of these, stateful session beans. I could have used that instead of a session scoped named bean. Okay, it's the same concept. It's managed differently, but it's the same idea. It would just look in a different place for it to find it. Okay, so the container takes care of all of the nitty-gritty stuff for you. Now, one of the things that is, you won't appreciate this now because your applications are so small. However, one of the points behind here is that the container and the server is smart enough to know, depending upon how you define these things, that if what you're looking for is not in the same JVM or not on the same machine, it will know where to go find it. That means that you could have beans that live on 10 other machines, and you as the developer, don't care. Okay? The system will help balance itself by going out and storing them where it needs or retrieving them from where it needs. And that's all done underneath the covers for you. So we'll see that when we talk about the EJBs. So here's an example of, again, as I said, this is in the same kind of vein as the JPAs themselves. Here's an EJB and a second one. Let's say these are the beans that we're talking about, and they have the entity references in them. If they happen to be the same container, that's fine. It will know how to do that. But it's also smart enough to be able to go find it if it's in another container someplace on another JVM on another machine. Okay. Now, when you have a transaction, whether it's an EJB transaction or a JPA transaction, if you're in the middle of one transaction and you call some method that actually starts another transaction, and this is true in both cases, either for the EJBs or the JPA entities. The normal default behavior is that the thing that you're calling becomes part of the first transaction. Okay, so it's like one bigger transaction. But you can say, no, I want those to be treated separately. I want this one to effectively halt and wait, go off, do that one, treat it as a totally separate transaction. So in fact, if it fails, the only effect will be whatever it was doing, and then it will come back, and then I can continue. So that's another possibility. The default is to treat it all as one. Or you might not want the thing that you call to be part of any transaction. You can just simply say, no, don't, I'm doing something else, never mind till I get back. And then there are different variations on this, but that's under your control. Mostly using the annotation attributes. And then again, as I said, one of the things that I can only say is important if you were to be building a huge system that's supporting many, many thousands of users, that you can actually, with a simple annotation, say, okay, this thing will be somewhere else. That's okay. So here's an example. This happens to be, this is actually a combination example. I'm getting ahead of myself a little bit here. The blue part there are all the annotations. The stateless, that is, I've told you a little bit about that, and you've also done some reading, so you have some idea what I'm talking about. That is a stateless session bean, okay? And I'll get into more, make sure I go over the details of what that is, how that works and everything. But here, it's simply holding the real example for us here, which is the JPA stuff. There's the persistence context, okay? You notice there's one of those attribute things inside the annotation. That turns out to be redundant. That thing there is actually the default, so you don't actually need to say it. So you can just say persistence context, okay? If you said, I think I have another example later on, if it says .bean, then you're in bean managed. And then the methods that you would see below would be different, okay? But again, it will give you more control. All right. Transaction attribute. This is what I was saying. This is if you were in one transaction. This constitutes a transaction as soon as you do account open, that method. And basically, what you're saying is that treat it as if I go out someplace else, treat it as a single transaction. That is also the default, which is why you don't have to say it most of the time. But I just wanted to show you that often these annotations will have these attributes that allow you to give more information about what you're doing. So here, basically what happens is the persistence context gives us an entity manager to work with. When you call this method, the open method with an account number from wherever else in your code you are, what it's going to do is it's going to ask the entity manager to find, using this account class, this is just the way that the call works, it's going to look for the account number. So basically what this is doing is it's going to say if it exists, throw an exception, otherwise let me know, okay? Or otherwise go do it, I'm sorry, otherwise attempt to insert it, open the account. So if the account equals null, of course that means there is none, okay? It returned a null, which means it couldn't find it. Then that's our clue to say go ahead and actually create one now. So we'd create a new account object, give it the name and account number, okay, you see that? And then here's the other call. This is the other thing. This is what actually takes it. The new account actually created the instance. It's saying persist, which is actually going to say, okay, now hook it into synchronize it with the database. And then return the account. So in this case, because that's the end of the method, that is the commit at that point. And then of course, the else would, in this case, it'll throw an EJB exception because we're inside of a session bean. But that's basically all there is to it, is that, okay? So there are actually two calls. well, in this case, you don't even need to find. You can simply just say to persist. And then you can do updates, blah, blah, blah. You can make changes to the thing, and it'll automatically, write them out to the database when it's time. Okay? So that's the basic idea. Okay? Now, this is the other flavor. Okay? Application managed, being managed, same thing. In this case, you have to take a little bit more control, but you then also get more fine-grained access to the thing. You specify when the transaction begins and when it ends, when it commits, and when it does a rollback. It's more like what you probably used to from the database world, using whatever code you were using, like JDBC, which you might have been using in your other class. And the whole point is there's more work involved on your part, but it gives you more control. So when would you use it? Basically, as I said, using the container managed, you're basically limited to the transaction boundary is the method, okay? Or any methods that it calls, unless you say those are not part of the transaction. So that's, again, why you keep them pretty concise and to the point. Because you're relying on the container to do everything for you, okay? In this case, however, maybe that's not good enough. Maybe you have multiple different kinds of transactions inside of the method, okay? And you want one to do something, then commit, and then you want the second thing to do something, and if it fails, that's okay. If the two different transactions didn't both succeed, I can deal with that. That you couldn't do in the container managed, because you only get one transaction that you're working with. Here you can have as many as you want, but you also then have to do more work to say how it works. Okay? So here's, again, why would you want it? That's the major reason, if you need to get to that finer level. The trade-off, again, more control, but more effort. The tip, as I said, if you can get away with using just the vanilla container managed, much easier because you don't have to do as much. Okay, but I mean, if you're having trouble getting your model to your business logic to fit into this, you might have to go this route. But in general, you don't want to. So here you'll see this is slightly different. Okay, it looks similar. Again, this is actually inside of an EJB, is the session stateless bean. Notice the transaction management annotation. That's where we say, in this case, we have to say this. This is not the default. Resource, that is another injection type. Essentially, it says this particular case, it's another resource that is provided to you called user transactions. This is the actual transaction object that you need in order to begin a transaction, commit, rollback. Okay, this is the thing that you call. And persistence context, you say that. That's the same as before. So you still need the entity manager. Let's see here. So in this case, now here's an example of why you might want to do this. This piece of code, obviously there's more to it than you see here, but basically it says save multiple new customers. Now what you're doing here is you're giving it a list of customers, and then you're going to step through them one by one and attempt to essentially create a new one and then persist it to the database and then commit it. So they would be, create a new one, get me the right next ID, persist to the database, commit. Okay. Now, if for some reason that an exception gets thrown inside there, let's say that the number exists already, okay, that might throw an exception in the database. So what would happen then is, in the case if this were container managed, all of them, if you had 100 of these and you were on the 100th one and all the other 99 had succeeded, they'd all be rolled back. Okay? So, which in a lot of cases is exactly what you want. Okay? However, in this case, if you're saying, okay, out of the 100, I'm willing to live with the fact that as long as I know which ones they were, this one failed, that one failed, that's okay, I'll deal with them separately. So in this case, it doesn't. The exception doesn't stop the transaction You see, so that's an example of why you might want to do this. Okay? But again, the rule of thumb is, if you don't have to do it this way, if you can imagine, you could rewrite this in such a way that the single transaction is its own method. Instead of saving, in other words, you would remove this out of one level, okay, so that the entity management is only attempting to do one at a time. And then you call that thing inside of a loop, okay? And so there you get the container managed for free then without having to do some of the rest of this, okay? All the modern Java EE servers that exist have support for this nowadays. You can actually, if you're using something like Tomcat, which is a servlet container, which is not a full EE server but has a lot of pieces, or something else, your own desktop application you can do this with. You can actually import the code into your Java application and get the benefit of the JPA stuff. Okay. So the EntityManager API basically consists of persist, that inserts the entity into the database, find, does a simple query on a primary key, merge, again, if the thing gets in that detached state, it'll bring it back into the context, delete, that means remove it from the database, which doesn't happen again immediately. It happens when the whole thing terminates or the commit happens, or a flush, which you would call. Clear causes all the managed entities to become detached. I'm not exactly sure when you would do that, but you can. Refresh, in this case, if for some reason you think that, and this happens sometimes depending upon how you write your code, you could sort of get out of sync with the current state of the database. Oh, actually, if somebody else is making changes to the database simultaneously, you might need to do a refresh to make sure that you've got the most recent version of whatever it is you're dealing with. So you might have to call that once in a while. Contains, that's simply to ask, is the entity that you think that you have a handle on, is that actually being managed by this persistence context? Flush, that forces the synchronization. In other words, anything that's supposed to be written out or removed will be done. And then here, these last three have to do with the basic query mechanism. There's find, which I just showed you. That's simply a key, the primary key lookup. If you want to do something more, like a select where user ID equals this and the date is that and the guy's name is Fred and blah, blah, that kind of query, these are the one of the sets of tools that you would use. Create query, that's a dynamic query. Okay, it allows you to essentially write SQL-ish type of queries. Okay, now again, this uses what is called the JPQL, which is very SQL-like, but is not SQL. Okay, I mean it's easy to go back and forth, but just beware, it's not literally SQL. That is the first one is extremely flexible, but kind of performance-wise not as good. Okay, you're familiar with the idea of prepared statements? Everybody knows what that is, and you know why you use them?
For security purpose, like SQL injection.
Actually, yes, that's another reason. But the main reason, though, probably is more performance reasons.
Dynamic query?
I'm sorry?
Dynamic query?
That's the first one. That's create query. That's a dynamic query. The reason that, yes, you're right about the security, but the major reason you do prepared statements, which is effectively what we're talking about here, is because the underlying database can map out its query strategy. Okay, you familiar with that concept about optimization, database optimization? And because you're effectively creating and locking in the query once, the database can optimize that and simply use it again and again and again, with different arguments, different parameters, yes. From what you know, with prepared statements, the same idea exists here. Dynamically, that means it could be exactly the same query, but it basically has to recreate it every single time it gets called. So any optimization that it could have done, it has to do it again and again and again. That's really the benefit of prepared statements, the basic reason that you use them. Same thing. Okay? Here we call them named queries. Okay? But it's, if you know prepared statements, that's really what they look like. And then if you need to, the native means real SQL. Okay? So if you have something that's some kind of weird inner outer join view, you know, group by blah blah that you can't, for some reason the JPQL doesn't allow you to do, or easily, you can always drop into native SQL. This is kind of like your last resort if you need to get down to that level. Now, this JPQL, I'll get back to this, is only one of two basic ways that JPA allows you to do querying and updates and inserts. The other one is, I don't have enough time to get into it, but if you like a more Java style version of that, there's something called the Criteria API, okay? Which is, honestly for me, since I came from an SQL background more, I find it a little awkward looking, but if you like writing more Java and less SQL-ish looking stuff, the Criteria API might be for you, okay? But I'm not really going to go into it too much. It's probably more, slightly better performing too, but I'll leave that to you to look into if you're interested. Okay, so just a couple of these. Persist, again, it inserts the new entity. It doesn't create it. It simply says, okay, now take it and actually moves it from that detached state into a managed state. So here's, well, you've already seen an example. In this case, the new is actually creating the instance, but it's the persist that actually hooks it in that says JPA manage, in this case, container manage it for me. So in this case, simply by doing the persist and then returning, the commit will happen upon the return, okay, automatically. You don't even have to say it. Find and remove, you often see these used together, because if you want to remove something, you've got to get the key for it, or you've got to get a handle on the instance itself, and you use the ID to do that. So you typically will do something like this, you'll often see this, where you do the find first. That will give you the instance that you're looking to do something to, and then the remove, in this case, would actually remove it, and then it would, again, this would terminate here, and the remove would happen after the method returns. Okay? Still very common. Merge, this is, again, when the object is detached for some reason. And in effect, in some ways, you could use this in place of persist, if you think about it, all the time. Yeah, and I read some online things that, people ask, well, really, what's the difference? I mean, persist only you use when the thing is new, it's never been under control, and merge means that it may or may not have been under control, so why do you need persist? And there was some, I don't know, performance-related thing, but in general, you would use them as a pair. You would persist the thing once, and then thereafter, if somehow it got into a detached state, or you were bringing in something from another transaction, that's the other time, another persistence context, that's the other time you might need to use merge, to merge it into your current persistence context. That's the way, it sounds like an odd word, but maybe that's the easiest way to think about what it's doing. It doesn't directly update the database, okay? It's just saying I'm pulling it back in to become managed. It's only when it's committed, flushed, removed, whatever, that it really is updated in the database. So it's kind of like a two-step process. As I said, normally merge is not required. Normally what you do is you would persist the object so you get a handle on it, then you just operate on it, okay, using the getters and setters that you normally would, or anything else that get at the properties in the object. Any change you make to the property in the object is, assuming everything is, there are no exceptions, is going to get propagated to the database automatically for you. But there are times when this merging might actually be useful. So, how do you actually use this? Well, you already have. Your simple, and I'm gonna, when we finish this, I'll go over the vanilla version of the simple EE6 app, just to show you how all of this relates to what you've already been doing. Because you've been using this for a long time. You might not have appreciated what you were doing, but it was already in there. So in the, obviously somewhere along the line, you've got to make the association between this persistence context and a real database, that's being managed somehow, somewhere. And that's done using in this case, the persistence.xml file. If you're using Hibernate, it would be called hibernate.xml. But in there would be an XML tag called persistence unit, and it's basically a logical grouping of all of the entity objects that are, or classes that are being managed under that persistence context. And it's easy enough if you didn't have one. As soon as you create a project that is using JPA, which is just you check that off in the beginning, it will create the persistence XML for you. If for some reason you're retrofitting something and you're adding it later on, you can create it yourself by hand just by doing this. Now, what goes inside of it? Here's an example. Actually, is this the one? No, this actually, I have yours too. This is actually coming from another project. But basically, if you look here, this is the XML file. If you look down to here, if you look down to here, this is the persistence unit I'm talking about. The name there, that would be the name of your context, your persistence context, the one that you say on the persistence context inside the parentheses and the quotes. Now, you may have noticed on the previous example, it didn't say anything about which persistence context to use, right? It just said @ persistence context, give me an EntityManager, right? So you might ask yourself, well, how did it know which one to use? The answer is, if there's only one in the file, that's the one it uses. Okay? So again, you see how this thread of, if you don't have to say it, if that's what if that's the default behavior, don't make the programmer do it. Okay? So that's actually how that works. Now, you can always add the name equals, this. In this case, it's called email list PU, persistence unit. Or again, as I said, the real reason that you would normally do that is if you have more than one. You have this database you're hooked into, that one and that one, so you obviously have to give them names so that you can specify which one you're trying to get access to. This case, the transaction type is called resource local. That means it's being locally managed. This is not what you would normally do. You use the JTA, the transaction, that's the server itself. You remember what I said? One of the things is that you could run all of this in a totally standalone Java application. Okay? If you pull in the JPA libraries into your Java application, you can have just running on your machine. It has nothing to do with the web. It has nothing to do with Java EE or any of that stuff. You could use all of the same facility, and it would simply become part of your application. That's resource local is more what you would see in a case like that. Let's see here. What have we got? And you'll see down at the bottom, this is actually, this example I took from a Tomcat application, which is not, again, is not Glassfish. It's a servlet container, which means it's got a lot of the Java EE stuff, but not all of it. So, for example, you'll see here that here is the URL for the where does the database live. Okay, you'll see it says it's a MySQL database, local host on my machine, 3306, which is the MySQL port, and then it's called that name. Then here, this is the property for the user. In that case, it's root, password, sesame, and the driver is then MySQL error. So this is one way you might find this. Okay? In our case, since we're using Glassfish, if you look in your persistence XML file, you won't see that because it does it slightly differently. It uses what are called connection pools. And it uses the same JDBC stuff, but it's more geared towards a higher volume environment. Now you can do that sort of stuff with Tomcat too, but it's done slightly differently. Here, if you use Glassfish or Wildfly or one of those, that whole concept is more or less assumed that you're going to do some serious, thousands of connections a second or whatever. So it sets it up for you to make that more better performing. Anyway, so you'll find one of those, and yours, as you'll see, is actually smaller. So basically, the persistence unit, that's what I just described. These are the XML things. The provider, that's where you say what class it is. Now, the third thing was what I wanted to mention, is generally speaking, this again, remember I said the default behavior is to do what you do 90% of the time. In this case, you say, I want all the classes to be controlled. Okay? This allows you to say, except for these. Okay? So you can actually say, don't use them all. I'll tell you which ones I want to be under your control. Okay? So again, the same kind of philosophy. If you're doing it 99% of the time, then make it easy. Okay? Don't make them say anything more than they need to. However, give them an out so that they can actually do something else if they have to. And oftentimes that's either by adding more attributes to the annotations or using a config file, one of these XML files, which allows you to override things, or add special cases. It's the same idea with the navigation, right? The faces navigation. I mean, you don't need that stuff, that navigation stuff in the faces config file. I mean, it's more elegant and it's probably a better design, but you don't have to do it, right? Because there's a default way things work. Okay, same idea. Okay, just in a different place. Oh, here's yours. This is the one from that vanilla application. So in this case, the persistence unit was called, a lot of them are called PU. That's usually what you see. The transaction type is JTA. This is the full-blown container managed thing. Turns out it's the same provider. That is, this is the Eclipse link provider. It could have been Hibernate. You'll see in a lot of other cases. Here, now, this is slightly different. This is because we're using Glassfish. Instead of having all of those details that we saw about the database and where it was, that stuff is actually in the Glassfish configuration. We're simply referring to it here. Okay? So the JTA data source is this thing called JDBC/sample. So it's a JDBC string. JDBC uses this path name kind of idea. It's actually, and I haven't gotten into this very much, it's actually part of something called JIND, the Java Naming and Directory Interface. That is, just in general, I'll mention as an aside, is a capability or tool that allows you to find things, objects, JDBC connections, all kinds of Java-ish things in a Java environment. Okay, it's a way of defining where something lives. It's kind of like a URL. At least that's what you often see them as. And the JIND itself is a part of the Java EE services that allow you to find things like that. Okay. So in this case, what we're going to see is this thing called JDBC/sample. Here, there's that other thing, exclude unlisted classes false. So again, this is by default, it's saying if it's a class, make it an entity. Let's see, what else? And then the last thing I wanted to point out, remember what I said before? This is even to the point, this is, and as a matter of fact, this is why that worked. This application actually managed to write things to the database for you, and you didn't even know there was a database there. Because if the, in this case, it didn't need, it's wide open in terms of the user and the password because it's on your machine. It's just a test, test kind of database. You notice it says create tables. So the very first time when it saw the entities, if this thing didn't exist already, this samples database, it would actually have created the tables for you. And they would, of course, be empty, but they would be there. Okay, so the JPA annotations entity you've seen, ID, there are only a few that are really you're going to always see. Entity, obviously. Generally speaking, you're always going to see @ID because you need to say what is the primary key. It's often, and by the way, it's a good idea in general, to create for each of your tables is to create a completely separate primary key that has nothing to do with the data itself. That's just as a general rule of thumb. That's not a bad idea. You know what I'm saying? So if you have a table that's, user ID, username, blah, 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 the first column should not be user ID, even if it's unique, make it, ID. And simple enough, just make them a sequential long, or anything like that. So that's what this is referring to. I mean, it could have been user ID if it were unique, but that gets messy for other reasons, so that's not necessarily a good design idea. Generated value, this is, let's say you have that column, and you say, how do you make it? If I create a new row, where does the number come from? And of course, there are many different possibilities. The database will do it for you. And this is a case where in the attributes in the parentheses after this gives you like 5 different possibilities that you could use. But I'll show you an example. Again, here's another one, @table. You might not have even seen it in some of your examples, because again, if you're happy with allowing the database table name to be the same as the class name, you don't have to say anything, okay? However, if you want it to be something else, like you want it to be all uppercase, or have underscores in it, or give it some other name that means something, you can. Likewise with the columns, okay? If you want to override those, then you would say @column and give it a name. Otherwise, it will use the name of the property or the field, okay, to define the columns. So again, convention over configuration. If you're happy with it, then don't futz with it. So here's the minimal example of this. Have to say entity. That's what you're defining this class to be. You should implement it as serializable, okay, because it is conceivable that the server might want to write it out somewhere, and so that it can get it out of the way until it needs it again. Okay, this is all going on underneath you. You don't see this, but by making it serializable, that's what that means. Okay, it allows it to be able to serialize it out into a format that can be stored and transmitted easily, and then if it will handle doing that, it'll handle bringing it back and unserializing it. It's also, have you ever heard the terms marshalling and unmarshalling? Yeah? Yes? That's the same thing. Often, and as an aside, this second thing here, giving it a serial version UID, that's also not a bad idea. In some cases, I've had systems complain if you say something is serializable and you don't give it the this thing, serial version UID, and give it some kind of value. It doesn't have to be 1. It can be any long number. The reason it does that is because if you think about this, you serialized something, it's been sitting there for a week on the secondary storage, and you changed the class in the meantime. How is the system going to know if the class, let's say you added a field to the class in the meantime, how is it going to know how does it unserialize it? Okay, because if the class now looks like it's like this, which has got this extra field in it, and the thing that it's serialized doesn't have it, what does it do? That's where the UIDs come in. The way it's supposed to work is if you make a real change. Let's say you're not just in quick turnaround mode doing stuff and testing it. If you have a deployed system, then if you're going to make a change to the class, usually by adding something. It's rare that you remove something. Okay, it's just not the nature of things because too many things depend on what's in there already. So you might add a method, some other fields or something like that. You would give it a different UID. Okay, and so the system could then distinguish between the two of them and know which one is which, so that it could keep them separated. Anyway, that's the point behind that. But so here is the other annotations, ID and generated value. Now you notice what they're doing is they're sitting right above the field, private long ID. Okay, so that is what they are modifying. So it's saying basically use this field ID as the database ID, the thing that's going to be the unique generator. And in this case, I don't remember if this is the default or not, but this is a safe one to use. Strategy equals .auto, okay? Which means basically let the database do whatever it likes to do. But if you look it up, there are like 4 or 5 different possibilities, okay? But any of them will work for you, okay? They will guarantee uniqueness, which is all you really care about. And then the rest of them, now you notice there's nothing else. Okay, I mean, this actually, no, was this the end? Let me see, is there more? No. There might have actually been more stuff in here, but you notice there's no other reference to table or column or anything like that. So what's going to happen is it's going to say, this is called message. So what you're going to find is, and if you think about it, if you look in the Java DB database on your machine, there was a table called message, right? That's where it came from. Likewise, there was a column called ID. That was the first one. There was a column called message. And by the way, I hate this example because they use the word message in 3 different ways, which can be confusing to folks the first time around. And if you were confused, fine, I was too. I would have called it something else, MSG, I don't know, anything, so you knew that this was a message and that was the message inside the message. You got confused? Yeah, I'm sorry. I didn't make it up. Unfortunately, it's just I happen to like this example except for that problem. Anyway, so that's, if you look in there, there'll be, I think there are only 2 columns, the ID and the message, because there's nothing else in there, I don't think. And this is where they came from. As a matter of fact, in your case, if that database or didn't exist, or the table didn't exist in this database, it would have, based upon the other thing you saw before in the XML file, it would have actually created it for you, and this is how it knows how to do it. But you could have, if you said, I really didn't want to call this thing message, I wanted to call it, user post or something like that, then what would happen is it would have created the table, and you wanted to call the table, what is it called? It's called message here. Let's say user messages or something like that. It would, and you'd said @table user messages and @column user post. Then if you looked at the database, you would have found the table was called user messages and the column would have been called user post instead. Okay? So that's completely up to you. But again, the default is take the easiest route, and that's what you get. Okay. Now, here's another example. This is completely different from the other one. This is where the defaults are getting overridden, just to give you a little flavor of the kinds of things you can do. In this case, the class is called country, big COUNTRY, but they wanted the table to be named countries. Okay, and they wanted it to live in a particular schema within the database. What else we got here? Okay, the ID, that's same. Column, this is an example, because the field is called country ID, and they want it to be called more database-ish country underscore ID. You know, that's more like you would see in a SQL relational table. And also, as you can see here, there are actually other things that you can do. This is yet another example of doing validation. This is not the beam validation. This is yet another validation. This is the JPA validation that you can do. In other words, this is designed really right at the database itself. In other words, you're telling the database, make sure this column is unique. Make sure it cannot be null. Okay? Make sure it's only 2. So this really makes sense if you're starting with this and telling the system JPA to create the tables. Because otherwise you would be doing it the other way around. When you created the database schema, you would have said that column was not null, length 2, blah, blah, blah. Okay? But you see how that goes both ways. Let's see what else. So again, I'm just showing you how you can override things. The country name, region ID, precision, you see, there's another field for the region. And then down later on, we'll get into this a little more later, this associations, okay, because obviously tables don't usually live by themselves, they're often related to other tables. So here's an example of this particular one. We're talking about employees and countries, I guess, that they live in or they work in. And so there's a relationship between this table, which is the countries, and the employees table, right? And this would be a one-to-many relationship, okay? Because obviously in this case, one employee can only live in one country, but one country can house many, many employees. So there's the one-to-many for you. One thing I'll mention right here, because there's no other convenient place to mention this. Yeah.
Country is a class.
I'm sorry? Yeah, you're not, country is the class.
Okay.
See?
Okay.
Yeah, say it. Yeah, which one?
The second. The one-to-many mapped by country.
Yeah, that's what we're talking about here.
Okay.
Okay? Country is the,
Class. It's capital and the mapped by is small.
let me see, what are we doing here?
Small.
What that is country in the employee. Well, we don't see this. Okay, you can't see it because we don't have the schema, the table layout for employee. The other table, country is one of the columns in the table. There in that table, they're referring to this country as country. Yeah, because you don't see the other side of it, you don't. But that's where it's coming from. Okay, because that's what's happening. And when you're doing these kinds of relationships, you basically have to describe both sides. You say, I'm the control, I'm the owner, and then I've got a lot of you guys. But the other side, it depends if it's what you call unidirectional, then you really don't care so much about being able to work backwards from there. If it's bidirectional, which in this case, that's where the mapped by comes from. Because they not only want to be able to say, I guess, because I don't have the whole code, so I don't know. They not only want to be able to say which employees live in which country, they want to say, for a particular country, which employees live in it. See what I mean? That's what would be called, that would be bidirectional mapping, okay? So yes, so the country, that's actually coming from the other, I'm sorry, actually it's coming not from, well, ultimately it's coming from the other table, but country is actually coming from the other object, the other entity, from the employee entity, which of course we don't see here, I don't have it, but that's where it's from. And the other thing I wanted to point out, as long as they had an example of it here, was this fetch type. You'll see this, there are two fetch types, eager and lazy. And basically what you're saying, and this actually has performance implications. So if you say eager, that means when you make this association, go out and grab all of them at once. Okay, do all of them. Now, in this case, that's probably not such a bad thing because there are only, maximum of 200 countries in the world. So that's not such a big deal. But in other cases, you might want to say lazy, which means only get them as I need them. Okay? Because if you came back with 1,000,000 rows, you wouldn't want to do that every single time you did this. See what I mean? So in that case, you would say fetch type lazy, which means only as I ask for them, bring them back. Here you're saying bring them all back at once. Okay? That's what eager means. And you'll see that in other examples. Okay. Now, those annotations, where do you put them in the entity? You actually have two choices. You can either use what are called the getter annotations, or you can use field annotations. The field annotations mean that I'll show you the example, make it obvious. You can say, where am I doing the mapping? Do I do the mapping based upon simply the field, or do I do the mapping based upon the get of the field? And those are different if you think about it. The difference is if you do it simply based upon the field, like string, username, whatever, okay, as opposed to putting the annotation on the get username method. Get username method might actually do a bunch of other things, like take the first name and concatenate it with the last name, and then put the junior, third, whatever at the end, and that becomes the name, you see? So if you did the first kind, what I'll show you, and by the way, you can't mix these together. If you're going to do one, you're going to have to do an all for that class. So what I'm talking about is this. Here is the getter style. In other words, the user ID here is what is getting modified by the thing. Okay, the get user ID method versus this, which is the field style. So the basic idea is the fact that if you do it this way, if the get, what user ID turns out to be is actually not just a simple value, like you go through 3 steps in order to create the user ID, and that's what gets saved. You see, you can't do this way because you'll lose that. That's the choice. Okay, so. Yeah, I mean, it's up to you. I mean, if all you ever do is simply, put a value in and get it back out, put a value in and get it back out, then you can use either one, and it's, you don't lose anything. Now, this whole topic can get very confusing, and I don't really have enough time to get into a lot of examples of how this works, but I will try to give you a flavor for this. Now, what I'm going to rely on is the fact that what you're developing is not going to be very complicated in terms of interrelationships, and if you do a decent database design, that NetBeans will help you by figuring this out for you most of the time. Okay, so but I want you to at least understand in principle what's going on. If you could take, I subscribe to one Java newsletter where the guy is a Hibernate expert. And he could teach entire weeks-long classes in how to do this properly using, the Hibernate, which is essentially the same as what we're talking about here. So it can get very complicated, and I'm going to try to keep it simple as much as possible. But the entity relationships I'm talking about are, a customer could have one and only one username, all right? So that's a one-to-one, and one and only one home address. But they could have many orders. The orders could contain many line items, so that you've got these 12 things that you just ordered. But each line item contains only one particular product. It may have a quantity and a price and everything, but it's only one of them. So you see that there are all of these different kinds of relationships between the tables and columns, and so on. So that's just a simple example of these relationships. So these are represented in this terminology by one-to-one, one-to-many, many-to-one, and many-to-many. Okay, that actually pretty much describes any kind of relationship between two different things or two different tables. So in a more formal sense, the way you can think about this is there are like 4 different attributes that these are talking about. One is the role. how are the two things, because you're always talking about two different things, how are they related to each other? And each one plays a role in the relationship. In other words, one is the owner, and the other one is the thing that's owned. Okay. Direction. This is what I was saying before. You can either be interested in simply the one direction, going from one to the other, or bidirectional. So here's a person having an address is normally unidirectional, right? Because you're usually looking from the person to the address. Whereas an employee that happens to be part of a project is normally bidirectional, because the employee is part of a project, and the project contains any number of employees. Okay, so that would be bidirectional, because usually you would want to be able to answer those two questions. Okay, that could be true in the first one also, but usually, if you think about it, if you're simply talking about a person, you're not asking who lives at that home address in most systems. You might, but that would be a different kind of system. Normally, if it's just a normal user in your system, you already know what their home address is. So you want to find out what that, you know their name, and you want to find out what their home address is, not the other way around. So you see how that's more unidirectional. But it depends upon the situation, what it is you're trying to do. Cardinality. Cardinality defines the number. This is where you go 0 or 1 to many, 1 to 1, 1 to many, many to 1, many to 0 or 1. That's the cardinality. And then ordinality basically is saying, is it 0 or 1? Do you have to have at least 1, or can it be 0? Is that a legitimate ordinality also? So that's kind of the things that you're thinking about when you're talking about these relationships. So one-to-one is a mutual relationship. But this is the default. If you don't say anything, this is the assumption that there's a one-to-one relationship. I'm talking about in JPA. And these, if it's bidirectional, however, which is what we just saw by the mapped by business, you have this concept of the owner and the non-owning side. So the non-owning side has to use that thing called map by. That's another annotation. And it's basically saying, I'm not the owner of this, but I have to say what it is that I'm relating through back to the other guy. Okay. So you remember the country, what you were just asking about? That was the map. That was the non-owner saying that, okay, what you're looking for me. If you're looking for me, the thing that you're keying off of is country, because that's what the country one is interested in. That's how it relates to the two tables together, is by the country ID. Many to one. Many entities can belong to another entity. So in the example I've got is people have phones and addresses and stuff. So you can have multiple phones, okay, per employee. So that's a many to one. One to many would be the other way around, let's say, if you're interested more in this. One employee can own many phones. So in these two situations, with both one to many or many to one side is always the owning side, is the boss. The other side is the one that uses the mapped by to say, how are they tied together, okay? Which you now saw a little example of. Not all the relationships have to be bidirectional, because many times you really don't care, because you're not going to be asking the question coming from the other direction, so you don't have to necessarily state it. Then don't bother. If you're really only traversing from one direction to the other, then, you could do it, but, it's just more overhead to maintain for no reason. So here's a simple example of here's an order, and then we've got customers. So obviously we now, just in principle, we know that customers have multiple orders, and orders belong to customers. So here's the class order. It's an entity. The table is called order. It's a many to one. So, and the join. Oh, this is another attribute. Another annotation, which somehow lost its closing parentheses, which is the owner side is saying the join comma is actually going to be in the other thing is the customer ID, okay? And then on the other side, they are doing it the opposite way around, which is saying I'm the one to the many, and it's going to be mapped by the customer field in me, okay? And that's what the other thing is going to be using to tie the two things together, okay? Here's another example. Here are two tables, an employee table and a phone table. The person can have multiple phone numbers. It's keyed off of, in the first table it's called emp ID, and the second table it's called owner ID. Okay, so sometimes simply because the tables have been constructed this way, they don't necessarily all have the same, they're talking about the same thing, but they have different names. Okay, so here you have the two entities. There's the employee entity. They're the ones who are going to own the phones, so that's a one-to-many. And we're also interested in the other direction in this case, so it is bidirectional. Excuse me. So the employee is going to map the, use the owner field, which now you're not seeing owner. Owner is the class field name, okay, not the table name. So that's why you don't see it here. It's actually, yeah, you don't actually see it here, but that's actually what's going on. So so there's the list of phones, and then the second one is the phone, and it's saying I belong to a particular owner, okay? And the join column here is that you're going to use to find it is the owner ID column, okay? So another simple example, but you see this takes a little practice to get the hang of. Here's another example where it's bidirectional. The thing I wanted to point out with this is if the application, and this is a bidirectional relationship, if the app updates one side of the relationship, then the other side needs to update. Okay, otherwise you're going to get out of sync. Okay, so here is when you add phones, then the when you add phones to the employee, then likewise you have to get the phones at the other side and set the owner. Okay, so it has to go both ways, which again logically makes sense. Otherwise, you're going to get out of sync. But it's something that you have to keep in mind. And again, I would say 95% of what you're going to see will be done for you, because it'll be pretty simple and straightforward. But I just want you to be aware that it can get much more complex. Okay. And then lastly, this is the many-to-many mapping. Okay. And I mean, oftentimes this is the example where things are bidirectional. Where here is the employees. There's a table of employees. There's a table of projects. An employee can belong to many projects. A project can hold many employees. So you can wind up with this many-to-many relationship. Oftentimes what you'll see is that a third table is created to hold the combined key that represents the two things linked together. Okay, so that's something you'll run across too. That's called the join table, which actually, I think we just saw it in one of the other examples, but that's actually essentially what it's doing. And it's a requirement for most of these many-to-many relationships. So again, this will often be created for you, but just beware that what you're doing. So here's actually, if you're going to specify it on this side, this is what you would have to say is something like this. You'd say it's many-to-many. The join table is this intermediary thing, and then you say what are the join columns and the inverse join columns, so you can look at it from one direction or the other direction. And you basically, this is what would create that intermediary table if it didn't exist. Okay, I mean, it's not that hard, but it does require a little thinking about what's going on. Okay. Okay. Actually, maybe we could take our 5-minute break, and I'll pick it up here and try to get into the EJB stuff as far as I can. But there are other, as you can see here, there are other